What is a location in terms of computer systems? How to store location in database? How will we calculate the distance between these two locations? How to search users within 5 kilometers? How location related data is stored in QuadTree? How insert works in QuadTree? Do we create a QuadTree for the whole world? How to build a QuadTree step by step with an example? How do we know which child to put into particular region in the QuadTree? Where to place this point B in this node? Where is QuadTree stored? How do we perform the search operation in QuadTree? When should you use the QuadTree? When not to use the QuadTree? What is the concept that we use in Geohash? How Geohash is stored? How is like Geohash different from the QuadTree? Because in QuadTree also you have like 4 different regions after the split. Here also when you are doing the splitting you have like 4 regions now. So how is Geohash splitting different from the QuadTree? What is S2? What is cell ID here? Now another question would come into your mind is like we said like we would have a path like this for the cell ID. So how will we store this cell ID? Where do you store it? And what is the use case? How big is a cell? How do we store location using the S2? How do we handle the range search in S2? What is covering in S2? How do we query efficiently in database for S2? How do we handle the dynamic locations like drivers are moving in Google's S2 library? What are the pros and cons of Google's S2 library? When to use S2 library for location? What is the difference in approach between QuadTree versus the GeoHash versus S2 library? How do we identify cell in S2? What is H3? How to store location related data in H3 for real systems? Let's see the difference between H3 and GeoHash. Now let's also see H3 versus S2. Do we implement ourselves like QuadTree or GeoHash, S2, H3? Or do we use the libraries? What do you actually build yourself? Like when you design systems like Yelp, Tinder, Uber, or maps, what do you use while designing these? Will you use QuadTree? Will you use like GeoHash? Will you use H3 or will you use S2? We need to design systems like Uber, Google Map, nearby locations, and much more. So all these systems have one thing in common. They deal with location related data. So in this video, we are going to discuss in detail about the location related data, how to store it, what are the different strategies that we can use to optimize storing and reading the location related data. Now this video can help you crack your dream company offer. So what I want from you is to make sure you like this video, subscribe to the channel and share this video with your friends and family so that I can create more such wonderful content for you. Hi, my name is Mohit Chabda, ex-Salesforce, ex-Walmart, and now let's start the video. Now talking about location, the first question that comes into mind is what is a location in terms of computer systems? So basically location is combination of latitude and longitude. So some of the examples are like this. For example, for Delhi, this is the latitude and this is the longitude. Similarly for Mumbai, this is the latitude and this is the longitude. So the combination of two numbers, that is the latitude and longitude, provides you location. Now this might sound complex, but actually you use it in real day-to-day life. For example, if I open Google Maps here, see I clicked on any of the place and this is the name and accordingly you can see the latitude and longitude, right? So every place, every location is identified by this combination of latitude and longitude. Now let's say I click somewhere else. Okay, I click here. Okay, and here you can see this is some different place, but this also has latitude and longitude. So based on latitude and longitude, you can uniquely define a location. So each of the locations, say I click near to this Wankhede Stadium also, this also has a longitude and latitude. So each of the location basically is defined by the longitude and latitude, right? So you can try this out in Google Maps. Just simply click on any place and based on that you will see a latitude and longitude for that location. So from this we understood location is basically the combination of latitude and longitude. Alright, now comes the main question, and the question is how to store location in database. Now what we will do is like we will discuss some of the approaches or the ways through which we can store the location in the database, and we will try to figure out what are the problems that we are facing with each of the approach. So pros and cons of each approach, and through that we'll get an understanding which approach is the best for which scenario. Alright, the first approach is the naive approach or the brute force that would come into your mind, which would be as location is just combination of two numbers, so we can store those two numbers as plain numbers, right? For example, we have a database table like user location. We will keep user ID in it. We will keep the latitude and the longitude, because location is combination of latitude and longitude. So we will keep these two fields, and of course we will have the user ID, right? So it would look something like this, like user ID is 1, this is the latitude and this is the longitude. User ID is 2, this is the latitude, longitude, and again user ID 3, latitude, and users longitude, right? Now let's say this is the location of user A, correct, and this is the location of user B, correct. So for each of the location we will have the latitude and longitude, correct. So here you can just imagine we are talking about user ID 1 and user ID 2, correct. Now the question comes, how will we calculate the distance between these two locations? So basically, because we have like two user locations here, so we will have the latitude and longitude for each of the user location. So we can use some formula like Haversine formula. Don't worry about the formula right now. It's basically you have like lat long for both of the locations, so we can use a formula through which we can calculate the distance. To make things more simpler to understand for you, you remember in maths we used to study like there was x-axis and there was y-axis, correct. So we were dealing with 2D, correct. So say there was this point, it would be something like x1 and y1, right, and then you would have another point here which would be x2 and y2, right. The basic maths we used to do earlier in our schools, correct. So if you had to find out distance between these 2 points, you would have a formula. I mean, there are many formulas, so we won't go into detailed math because we want to talk in technical details here. So you know that we can calculate distance between these 2 points which are present in 2D kind of plane, correct. So similarly, here x1 would represent the longitude of user A and y1 would represent the latitude of user A. Similarly, x2 is longitude of user 2, y2 is latitude of user 2, correct. And hence in similar way we can calculate the distance between these 2 points. Of course there can be some optimizations, and hence I said like there can be different formulas, like Haversine formula is 1, okay. So in this way we can calculate the distance between two locations. So basically till now everything is going good, okay. We are discussing the naive approach and things are looking fine, right. But the problem comes when we discuss this question, and the question is how to search users within 5 kilometers, okay. So earlier we discussed like we have like two locations and we want to calculate distance between two locations. That is totally fine, we can use some formula for that, correct. But what about like we know the current location of the user, okay. So this would have like the latitude and the longitude. So let me write here just to represent latitude and longitude, correct. So this has this location, okay. But you need to find out all the users which are within 5 kilometer range of this particular user. So how will you do that now? Now because we stored like the user location as like plain numbers, right, correct. We have like user ID, latitude and longitude. In case we need to find out users within 5 kilometer, what we need to do is like we will fetch all the users from the database, because in the database you will have the information of all the users, and inside the user we will have this information, user ID, latitude, longitude, right. So we'll fetch all the users from DB, and then for each of the user we will compute the distance. It would be same as like we had two locations, correct, and we can calculate the distance between these two locations, correct. And then we will simply check like if the distance is within 5 kilometer or not. In case this is less than 5 kilometer, then we will include that particular location, otherwise we will skip it. So one by one we will do it for all the user locations present in the database. Now this brute force approach is really bad. Why? Because say for example we have like 10 million users, so now we will have to scan like 10 million rows, because we will do it for all of the users in the database, and then this is extremely slow. And because we will do so many read operations on the database for each of the query like users within 5 kilometer, our database will die. So this approach is not at all scalable, and that is why the first approach that we discussed, the naive approach, where we store the location just as plain numbers, this is not scalable. So we don't use this approach for location data. So with this, let's move to the approach number 2, which is range filtering, which means that instead of checking all the users in the database, what we want to do is like check only those users which are roughly nearby to this current location. So as an example, say your location is this, correct? You have the latitude and longitude, and now we want the users within like 5 kilometer range. So what we will do is like instead of going through all of the users in the database, we will create some range boxes. So we will check the latitude between this range. You can see this range is near to the current location, the current latitude. So we have some of the latitudes which are lesser than this and some of the latitudes which are more than the current latitude, correct? And in similar term, we have the longitude. So this was a current longitude. So we have kept some of the longitude which are lesser than it and some of the longitude which are greater than it. So we have defined a kind of range. So this is the range kind of thing that we have defined, and this is the, you can say, the current location. So it would be something like this. This is our SQL query, like select star from users where latitude between these two ranges that we define here, correct? And the longitude between these two longitude ranges, correct? So we have kind of defined like min latitude, max latitude, min longitude and max longitude. So this is the query, and we are basically checking, we are trying to find all the users which lie between these ranges. Now once we get all the users which lie in this range, what we can do is like we can calculate the exact distance of that user from the current user, and then we can filter accordingly. If the distance is less than 5 kilometer, we will add that user in the list, correct? So here you can clearly see, instead of going through all of the users in the database, we have kind of specified one region. We are doing the range filtering, correct? Or we are bounding the box, right? Because we are defining the min and max for the latitude and the longitude, and in that range we are trying to filter out the users. And now let's discuss about the pros and cons related to this range filtering. So the first good point is like, because we have defined a range here, so we don't need to scan the complete database. So we scan only small region instead of all the users in the database, and hence it is much faster than the naive approach. Now coming on the cons part, of course, we have optimized from the previous approach, but still it is not that great. Why? Because it needs the indexing on latitude and longitude, because our queries are basically related to latitude and longitude, and in order to make our reads faster, we would need the indexing. Now if you want to know more about indexing and how databases work, you can refer to this crash course that I made on the database. This is more than 8 hours video crash course through which you will get the complete understanding of the different kind of databases and how things internally work in the database, right? So my big recommendation after this video, go check out this video and you will get huge amount of clarity about the databases in system design. Okay, so coming back to the topic, yes, it would require the indexing on lat long, and the next point is for very large data it would be still inefficient, because you are defining a box here, but still you can imagine there can be a case that there can be a huge amount of data can be present in the range that you have defined as well. Okay, and another point is it doesn't scale to like very big level when we talk about like design Uber application or design Google Maps. In that kind of case, this won't work. Okay, and many more designs we use like geospatial indexing. Now this is where the concepts like QuadTree, Geohash, H3, S2, all these come into picture. Now of course I know you would have a lot of questions like what are these things, but don't worry about it. What we will do in this video is like we will discuss each of these in very much detail. So let's start first with QuadTree. Okay, and a very basic question comes into mind is, what is QuadTree? Now basically we understood the problem statement, right? Like this is the user location, correct? The latitude and longitude. What we want is like all the users which are basically within 5 kilometers range to this current user, correct? So that was the problem statement. So what we don't want is like, we don't want to scan all the users in the database because that is not feasible. So in QuadTree, what we do is like, we kind of divide the area into smaller parts so that overall search becomes fast. I know it might sound confusing. So let me give you a very simple example through which you'll get a better understanding. Okay. So let's say this is the complete area. Okay. And now we will set like how many users, or you can say how many points this area can take, correct? Let's say we keep like maximum 5 users can be present in our area. Okay, so let's say the first user is here, the second user is here, the third user is here, again the fourth user is here, and the fifth user is say here. Okay, so we have these 5 users. Cool. Now these points are within this threshold because we defined the threshold as 5, correct? Now let's say one more user data comes. Okay, now we have 6 entries, but the threshold was 5. So now what we will do in the quad tree is like we will split it into multiple parts. And how many parts? As the name suggests, it's a quad tree. So every time we have to split the area, we will split it into 4 parts. That's why quad, correct? So what we will do here is like, let me split it into like 4 parts. Okay, by this we have done like 2 parts, and here also let me create a line. So you can see I have divided the region into 4 parts now, correct? By these 2 lines I have divided into 4 parts: region 1, region 2, region 3, region 4, correct? And now you can clearly see each of the region is again following this threshold, which means that each of the split area should have the number of users or points or anything you can say data points, correct, less than or equal to this threshold, right? So first region has 2 points, which is totally fine. This has 3, totally fine. 1, totally fine. 0, totally fine. So these are basically matching our condition, correct? So this is fine. Now let's say here in this region we get more data points, right? Like we have 4 now, and let's add one more, so we have 5 now, and let's add one more point here, so let me put one more here. So now again we have like 6 data points in this region, correct? So again what we will do is like split this region into 4 parts. All right, again you can see for this region I have divided it into 4 parts using these lines, this one and this one, right? We have 4 regions now, and each of the region follows this condition, right? Each of the region has less than 5 data points, which is true here. So clearly you can see the funda here. Anytime any particular region crosses this threshold, correct? Like for example here we took like 5 data points, so any region having more than 5 data points, we will split it into 4 parts. So again, if here say let's we have more data, 1 2 3 4, and then let's add more 5, right? And then add one more here, so 6 points. So again what we will do is like we will split this particular region into 4 parts. So clearly you can see I've divided this region into 4 parts, right? And now all of these parts are following this criteria. Now the important point if you see here is like I am dividing only that particular region which is crossing the threshold. Like for example this area had more points, so I only split this area into 4 parts. It's not like I am dividing all the regions. And again in this complete region if you see this part had this issue, so only this part we divided into further 4 parts. Okay, so it's not like we are dividing all of the things, only where we have a lot of data points which are crossing this threshold we divide that into 4 parts. Okay, and this process will keep on going. In case you have more data points here, it will split only this region into 4 more parts. So you can simply imagine like we will keep on splitting where there is huge amount of data points. And what's the use case of that? So the use case is, say for example we are into this region, say this is the user, and this user wants to find out all the users which are within 5-kilometer range or any range which is X kilometer, right? So because we have divided this region into some small area, so we would basically search only in this particular area and not in the complete huge region, right? So we will only search in this particular region. In case we get all the users, required users, say for example we wanted like top 2 or top 3 users which are near to the current user, we can get it directly from this area. In case we don't get, we can expand our search to the neighbors, correct? But only by searching in this area is also sometimes enough, correct? So this is the point of quad tree. So basically whenever you cross the threshold, you have more data points. Every time in that region you will split it into 4 parts, correct? That's why it's quad tree, 4 parts. And you will keep on doing that in case a region is like very heavy in data points, correct? So you will keep on doing that, and based on that you will get smaller regions, and it will become easier and faster to search in smaller regions. So I tried to explain you in this visual form. Now let's also see the same thing in more of a textual way so that you get more understanding. Okay, so these are the steps which we use on the quad tree. So the step one is you can imagine the earth or any area there where we want to focus on as a square, correct? So something like this is your region, correct? It is very same as like this region I created, right? So the same thing, you just imagine the earth or whatever region you are focusing on as a square. Now the next point would be, as I said earlier, you have some threshold, like what is the maximum data points that you want to keep in a like in that region. So whenever you cross that region, you basically divide the region into 4 parts, and because it's like 4 parts, that is why it's called like quad tree, because it would be like 4 quads, correct? So this was our original thing and we divided into 4 parts, correct? These are the 4 parts. Each piece is called as quadrant. Now one question may come into your mind, what is this NWNE SWSE? So basically this is northwest, northeast, southwest and southeast. How do you define it? Very simple, like just imagine this is like the 2D plane. You know that this is the north side, this is the south side, this is the west side, and this is the east side. So the basic geography that we study, right? And then so clearly you can see when we do this, we have like 4 areas here. So this area is between north and west, so this comes as northwest, correct? And that's what we have mentioned here, northwest. This area comes between north side and east side, and that's why it becomes like northeast. This comes between the west and the south, so it becomes like southwest, and this one between the south and east becomes the southeast, correct? So in similar way, when you divide the quadrant, you can define it as like 4 parts. Very simple logic that you can define. In similar way, we have defined it here. Okay, the next point is like you will store the data points in these locations or the regions, correct? And as we mentioned, like there would be a threshold that you define, like what are the maximum number of data points that you want to keep in that region, right? Say for example, earlier we took like the number of maximum data points were 5. Now here say we take it like 4 is the maximum data points that we want in a particular region, correct? So simple funda is whenever any box or region gets like data points more than the threshold which we defined 4 here, so anytime we get like more than 4 points, so we will split that region and split it into how many parts? Always 4, because it's a quad tree. So just like I defined it here, so for example the number of data points were more than 5, I split it into 4 parts, and again here you can see the number of data points were more than 5, again split. So depending on which region has more data points, we will split that region, and we will always split into 4 parts. Okay, so this was the step 3. Next, the step 4, as I said, like this would be the recursive splitting. In case your basically data grows in particular region, you will keep on splitting. So for example, in this area you have more data points, you will again split it into 4 parts, and again if specific area has more points, you will again split it into 4 more parts. Okay, so it is kind of, you will keep on doing it when your data points keep on increasing in particular region. Okay, so it can look something like this. First time you did it like 4 parts, northwest, northeast, southwest, southeast, like this. But it can be a case like in southwest you have more data points, like more than 4, then you will again split the southwest into 4 parts, right? So this will become northwest, northeast, southwest, southeast, right? So here you can see for the first one we split it again into 4 parts, but for others we did not split because in those regions the data points were less than whatever threshold we kept. So basically, as one of the region becomes more dense, we will keep on splitting that region into 4 smaller parts. Now why this kind of division makes sense? Because let's say like Delhi is a place where a lot of people live, and it has like 1 lakh cab drivers, just an estimate you can imagine. So it will keep on splitting the complete area in Delhi, and particular regions where you have more drivers, it will keep on splitting that multiple times, and you can search in those small regions because there are a lot of people out there, right? And similarly, when we talk about some desert area, say Uber is not supported here, correct? So we have 0 drivers there, so there is no point of splitting out there. That will be the complete region. Say for example, this is the region and there are no people out there, then there is no point of keep on splitting it. We only split it when you cross some threshold, right? So say for example, this area was very dense, so of course you'll keep on splitting it into smaller regions so that you can search quickly in that small area, correct? So basically the quad tree adapts to data density, right? Clearly you can see here this region was quite dense, so we did further splitting here, but we did not do it here, right? This was like complete empty kind of area. We don't see any data points here, right? So it depends on like what density you have. So the quad tree will keep on splitting in those regions. Okay. So now when we are discussing about the quad tree, one question comes into the mind. And the question is how location related data is stored in quad tree. Now, because I mentioned the location can be defined using the latitude and longitude, correct? So we are talking about the 2D plane, and mostly when we talk about the 2D plane, we can relate it with the maths or the geometry, right? Because in maths, horizontal thing we take it as like the x-axis, right? And the vertical plane we take it as the y-axis, correct? And if we talk in terms of like directions, we know like this side we call it as the north side, this one down we say it as the south side, this left side on the horizontal plane we call it as the west side, and the right side on the horizontal plane we call it the east side, right? Based on this we call this region between north and west as northwest, this region between north and east as northeast, this region between south and west as southwest, and this region between south and east as southeast, right? Now as we know, the x-axis represent the horizontal path and the y-axis represent the vertical path in maths. What about the location? We have two parameters, latitude and longitude. So what does each represent here? So the vertical plane is represented by the latitude, okay, and the horizontal plane, that is the x-axis, is represented by the longitude, okay. So latitude represents the vertical plane and longitude represents the horizontal plane. So we can say something like this. In maths, we say like x represents the horizontal, y represents the vertical. And when we talk in terms of location, the horizontal is represented by the longitude, right? And the vertical, that is the y-axis, is represented by the latitude. So you can say when the latitude increases, we are going to the north direction. When the latitude decreases, we are going to the south direction. Similarly, when the longitude increases, it means that we are going to the east direction. And when the longitude decreases, we are going to the west direction. So this is the basic thing to keep in mind. Like in quad tree, we divide it into 4 regions. So based on that, we get like northwest, northeast, southwest, and southeast. And the x-axis is representing the longitude and y-axis is representing the latitude. Now one question comes into mind, and that is how insert works in quad tree. Now as we know, in a quad tree, each node either contains the list of points or the 4 children, correct? So when we have to insert a point in quad tree, we will first check if the node is leaf and has space. So in case this is true, we will simply add a point into that node, right? For example, this is the node, right? And the maximum threshold we have kept as like say 5. So it can maximum contain 5 points. And currently there are 3 points only. So this is the leaf node because this does not contain any children because it has the capacity and it contains a list of points right now, right? And at the same time, we will also check if we are trying to insert a point into this node, will it exceed the threshold or not. Now because it had like 3 points, if we even add one new point here, that would be fine because even then the total number of points would be 4, whereas the threshold is 5. Okay, so in this case we will simply add the point into this node. But in case it is not true, by that I mean like say for example it already had like say 5 points, right? So 5 points were already present and now you are trying to insert the 6th point into this node, then you can clearly see the threshold is breached. And then in that case what we will do is like if it is not split, like in this case, because here it had like 5 points which was currently matching the threshold, but when you add a new point here then it will cross the threshold. So in that case you will split it into 4 children. Why 4 children? Because we are talking about the quad tree, right? And once we do that, we will insert in the right child. Otherwise, the other case is that this node is not the leaf node. It already had like 4 children. So based on that, we will select and insert into the correct children, right? And in that child also, we will simply check for the same logic, right? Because the child can also be in the situation that it might be a leaf node or it has space or the else cases, right? So overall this is the kind of pseudo code you can think of, right? So based on these conditions we will insert in a particular node in the quad tree. You don't need to remember this, but I just provided you the pseudo code I feel this is quite similar to what we do in the binary tree as well, right? When you try to solve the questions related to binary tree in DSA, we generally perform the same kind of recursive approach, or even for BST, correct? So in similar way here for quad tree, you can see the similar approach in case of insertion of the point. Now one question may come into your mind, and the question is, do we create a quad tree for the whole world? The answer is no. Basically we will create the quad trees only for the required regions, and on top of it we build them lazily, which means we build it on demand. So say for example we talk about some area where there is very less population, or your services are not present in that area, so there is no need to create the quad tree there, no need to store any data out there, right? And when we talk about a place where your services are quite famous or popular and there is huge amount of population, then of course based on the density of that area, your requirement, you would basically create the quad tree in that region and keep on splitting it, so that overall you need to search in small region. So quad tree would exist only where the data exists. So the basic point is, you won't create the quad tree for the whole world, you will just create it for the regions where your services are available. Say for example your product is like Uber, so you will create the quad tree only for the regions where Uber is providing the services, right? So instead of creating the quad tree for the complete world, we will choose the specific regions only. Now next, let's see how to build a quad tree step by step with an example. So let's say our services, our product is only available in India, okay? So instead of creating the quad tree for the complete world, we will create it specific to India, correct? Because there is no point of creating the quad tree for outside regions where our services are not actually present, correct? So let's say this is the initial boundary of our region. So as I told you earlier, we will have the min latitude and max latitude, similarly min longitude and max longitude, correct? So let's say the latitude is in range from 6 to 38. Of course when we talk about specific points, it is more precise, like 35.7521, like that. But in order to keep things simple in the example, let's say the latitude is in the range from 6 to 38 and longitude is in the range from 68 to 97. And in quad tree we know that the node structure is like each node has the boundary, which is the min latitude, max latitude, min longitude and max longitude. Now why is this? Because say this was our initial boundary, right? When we split into 4 quadrants, correct? So even then you will see the range. This is the starting point for this quadrant, like if we are talking about this area, correct? So then this is the starting point, then you have this point, then this point, and then this point, correct? So you have 4 points, and these define the basically range, the min and max latitude range and min and max longitude range, correct? So that part is represented by this boundary, and then you will have points, correct? So in case your region has lesser number of points as compared to the threshold, correct? So we will simply keep the points in it, which means this is a leaf node. And the other scenario can be, if there are more points than the threshold, then again we will split this area, correct? So we will do something like this. So now this area again is split into 4 parts. So that's why we would have this children array of size 4, which means like we have split the area even further. And then we have one more parameter, which is the capacity or the threshold, whatever you can say, which represents like what are the maximum number of points that can be present in the node. Now let's try to insert in the initial boundary of the quad tree, and through which we'll get more understanding. So this was our initial box, and we know the maximum capacity of each node is 2. So let's say the first location is Delhi, and this is the location of the Delhi, which consists of the latitude and longitude. So let's say this is the first point, okay? And let's say after this location 1, we get like location 2 as Noida, and for Noida I have created one more position, say here. Of course these positioning are based on the longitude and latitude. I will also tell you about that, like how are we doing this, but don't worry about that part for now. Now after this, say we get one more location, which is Gurgaon. Now clearly you can see in this node we already have like these 2 points, correct? And the maximum capacity of this node is 2, but now we need to insert one more point here. So we can't do that, because if we do that, we will cross the threshold or the capacity. So what we need to do now is like split this node into 4 children. So we want 4 quadrants. So let me do this. Okay, if you see now, we have 4 quadrants. Okay, and now we can insert this point. Say the third point comes here, correct? So 2 points, Delhi and Noida, are part of northeast region or this quadrant you can say, whereas Gurgaon point is present in the southeast region. So again, after this, say there is one more point that we need to insert, and that comes into this node. Then again we can see it would cross the threshold or the capacity. If that case happens, like if we need to insert one more point in this node, again we would split this region into 4 quadrants and then insert that point in the particular child. Now that in this example we mentioned that Delhi and Noida would come into this region, whereas Gurgaon would come into this region, the main question that comes into mind is how do we know which child to put into particular region in the quad tree? So basically we use this kind of logic while inserting the point in quad tree. I know this might sound bit confusing for now, but don't worry, let me try to explain it to you in very simple and easy way. Let's imagine this is our initial box. Okay, now we know that this would have some range: min lat, max lat, min longitude and max longitude. To keep things simple, let's say this is the range. Okay, latitude is from range 10 to 20 and longitude is in range from 30 to 40. Okay, and earlier as I told you, like in maths we used to follow x-axis and y-axis. X-axis was representing the horizontal, y-axis representing the vertical, correct? So this was x-axis and this was y-axis, correct? And I told you when we talk about latitude and longitude, the latitude is a vertical one. So let me write here LT, right? And longitude represents the horizontal, so LN. Okay, so now if we are given like latitude is from 10 to 20, so you can clearly see this is at higher height as compared to this one, correct? Because this is the vertical thing that we are talking about, correct? So clearly here the latitude would be 10, here also it would be 10, correct? And here the latitude would be 20 because the range is from 10 to 20. So let me write here 20, and here also we are at the same height, so here let me also write 20. So this is the latitude that we have. Now coming to the longitude, because we said like longitude is on the horizontal, so this is lesser as compared to this in terms of the horizontal, correct? Here if you go in this scale, of course it will increase. It's a basic thing like decimal system or any scale system that you see 0 1 2 3 4. Similarly this point will be smaller as compared to this point in terms of horizontal. So let me represent longitude with some other color. So let me put 30 here, let's put, and here let's put 40 because the range is from 30 to 40, so this would be the max one. Again here it would be like 30 because they are on the same x-axis here, right? A y-axis or the vertical path is different, but horizontally these points are on the same path. And here it would be 40. Now clearly we have like the min latitude, max latitude, min longitude and max longitude. Now what we need to do is like we need to calculate the mid latitude and mid longitude. Simply you can do like you need to find out the middle point of latitude. So we will do like min latitude plus max latitude divided by 2. So it's kind of you are simply doing the average or finding out the middle point. So clearly we know that the middle point would be here, correct? The middle of this complete region. And what would be the lat and long? Of course the mid latitude would be min latitude plus max latitude divided by 2, so it would be 10 plus 20 which is 30 divided by 2, so it would be 15. So let me write here 15. And what about the mid longitude would be minimum longitude plus maximum longitude divided by 2. Basically we are finding out simply the average or the middle point, correct? So that would be 30 plus 40 which is 70 divided by 2 which becomes 35, correct? 35 is mid of 30 and 40. So we have the middle point here. Now why are we calculating the middle point? Because when we will split this node into 4 parts, it would become something like you have like this and this, so you always cut at the middle point. So all the regions, this one, this one, this one, this one, after you basically split the area, all of these will connect at the middle point, right? All these regions, these, this one, this one, this one, this one are connected by this middle point. So using this middle point we will be able to understand like different regions. Currently we don't need to focus on this split area because currently we have not split it. We can basically put some points in this complete region for now because we have not crossed the threshold. It is currently empty. Now let's say point A comes with this location. So this represents the latitude and this represents the longitude. Now as I said, like latitude represents the vertical and longitude represents the horizontal. Now we know this midpoint. Midpoint has the latitude of 15, whereas of point A the latitude is 18, and as I said, latitude represents the vertical axis. So this point will be higher than the mid, correct? Because 18 is more than 15, so we need to go higher. We need to go on the north side, correct? And then when we talk about the longitude, which is 32 here, the middle longitude was 35, so we need to go on the left side because say this is a horizontal scale. Here if you go it will increase, here it will decrease. Simply if you remember the basic scaling, correct, the basic maths. So the decimal system, this you might think as 0. So if you go here it would be 1 2 3 4, right? And if you go this side it would be -1 -2 -3. So it would be decreasing this side, increasing this side, correct? And here the point had the longitude of 32 whereas the mid had 35, so we need to go this way. So we need to go up and this way. So this point A would be part of this region because we need to go up and this way. So this is the section where point A will come into. So let me write here somewhere here A. Basically this is the area where A would be present. And how did we do it? Basically we know the midpoints as we calculated, and then basically we simply applied the logic. And if you see our logic, it would be same as this one. Now again, if you see it as a formula, it becomes difficult to understand, but if you see in this way, it's quite simple to understand, right? The vertical one represents the latitude, horizontal represents the longitude. So based on that, if you think, this becomes so easy to understand. All right, so after point A, let's say the point B has location 19 and 38. Okay, so because we have kept the setting like in a node we can have two points, so currently it contains only one point A, so we can place one more point here without splitting this node. Now the question comes like where to place this point B in this node. So again the same thing that we did for A. So this is representing the latitude of point B and this represents the longitude of point B, correct? We already know the midpoint of this complete region or node, correct? So first if we talk about the latitude, the midpoint latitude was 15, the latitude of point B is 19. Now latitude is represented in the vertical direction, correct? So 19 is more than 15, so it will be in this upper direction, correct? Now next talking about the longitude, longitude of point B is 38, whereas for the midpoint it's 35. So 38 is greater than 35, hence we will go into this direction. So point B will lie somewhere here, okay, because we wanted to go up to the midpoint and to the right of the midpoint. So this region was where the B would be present. Now we have one more point here, which is a point C. As we said, like maximum number of points present in a node is kept as 2 here. Okay, it is conditional, it can be different for any other case, but let's say for this case we are taking as 2, so we cannot insert point C directly to this node. We will basically split this area into 4 parts. So you can imagine something like this we would do, right? So we are basically splitting it into 4 parts. Now still we would want to know like where to place this point C, correct? Again, if we simply talk about that midpoint thing, we know the midpoint was like 1535 for the complete one. Talking about the latitude of point C, it is 12, which is lesser than the midpoint. So we need to go downwards, correct? Because latitude represents the vertical direction and the C's latitude is lesser than the midpoint, so we will go down. Next, if we talk about the longitude, longitude of point C is 33, whereas the midpoint's longitude was 35. So the longitude of point C is also lesser than the midpoint, so we will go to the left side. So the point C would be present somewhere in this region. Now say there is one more point, point D, which has this latitude and longitude. Let's see where it will be placed. Okay, first talking about the latitude, latitude is 11, the midpoint's latitude was 15, so 11 is lesser than 15, so we will go down. Next talking about the longitude, longitude of point D is greater than the longitude of midpoint, so we will go to the right side. Hence point D would be present somewhere in this region. So let me write here D. Okay, so clearly based on this approach, we can insert the points in the region. So basically it is like if the latitude of the point is greater or equal to the mid latitude and the longitude of the point is smaller than the mid of longitude, then in that case, because this means, so you will go up and this represents you will go to the left, correct? So up and left, so this region, and hence it is northwest, correct? Why northwest? Because as we know in direction terms, like this is north side, this is south side, this is west side, and this is east side, correct? So if we are going up, so we are talking about the north side, and if we are going to the left side, it is west. Hence this region between north and west is known as northwest, correct? And similarly all other conditions are there, which we basically discussed in terms of example. So you don't need to remember this, but this is so basic, like if you take paper and pen and you remember basic things like latitude represents a vertical direction and longitude the horizontal, you can always recreate such kind of thing, and it is so easy for you to tell like where would this point come in this region. Right now, after this, next question which comes into mind is, where is QuadTree stored? Okay, to answer this, we have two scenarios. First, if we talk on small scale, and next if we talk on large scale. Okay, when we talk about the small scale, QuadTree can be stored in memory like in RAM, but when we talk about large scale, we use like disk based index, or you can say GIS engine, or we can use geo-spatial index. Okay, this is a very famous approach to store the location related data. So you can understand when we talk in large scale, so we don't code for creating the QuadTree. The geo-spatial index or other things, they already provide the functionality of the QuadTree. So we don't need to generally build it from the beginning level by ourselves. We generally use some of the things which already have the functionality of QuadTree, which we will learn about later in this video, don't worry. But what I wanted was like, I wanted to explain you bit about QuadTree, so that when you think about QuadTree, it shouldn't be the case like, okay, some other DB special index they implemented, so we don't need to know. It is like when you know about something, it gives you more clarity and you can think in a better way. Okay, now that you know what a QuadTree is, how the insertion works and how it splits the thing, it makes things better for you, right? It gives you more clarity. Okay, so that's why we are going step by step in this video. We'll discuss about QuadTree, we will discuss about geohashing, S2, H3, and then we will also see some of the database or the libraries or indexes which already have this functionality which we can directly use, right? And later we will also see like talking about different scenarios, like what to use when we are designing Google Maps, or what to use when we are designing Uber, or what to use when we are designing Tinder or Yellow Pages, correct? So we will discuss all of that part. So make sure you watch this video till the end, and also make sure you subscribe to the channel now, like this video and share it with your friends and family. All right. Okay. So after this, one more question that comes into mind is, how do we perform the search operation in QuadTree? So when we talk about the search operation, there can be two types of search which can happen in QuadTree. First one is point search, which means that you want to search a specific location in the QuadTree. So basically you are kind of checking, does this exact point exist in the QuadTree or not? And the second type of search is radius search. So it is like the nearby search. So for example, we want to find out all the nearby restaurants to our current location, say within 5 km radius. Now basically the strategy for both of these is different. Why? Let's understand this. So basically the point search represents the case where we are trying to search for the exact location. So basically like we have this location, latitude is 7, longitude is 3, and we want to see at exactly this location driver is present, or any restaurant is present, or any specific thing that we want to check, correct? So that is point search. And how will we perform this? We will use the same midpoint logic that we use for insertion, correct? Like we discussed about the insert case here, right? All these things that we had, and based on the midpoint we decided like where would that point be located, right? In similar way we can use this approach for the point search, because we are searching for the specific point in the point search. Okay, so as we calculated the mid latitude and mid longitude, we'll compute it here and we will decide which quadrant the point will be, and then we will only go to one of the child or one of the quadrants, because in quad tree whenever you split it into four parts, correct? So here, because we are doing point search, so we will only go to one of the four children. We will go to only one of the quadrants based on the approach that we just saw for the insert case. We will use the same approach here, and we will repeat this process until we reach the leaf node. Leaf node is the node which contains the list of points and there are no further children, which means we have not performed split any further on that particular region, correct? So that region only contains the list of points. So we will simply then match from that list of points. If we get a match, then we found that the driver or restaurant or whatever thing that we have mapped it is present at that particular location. And if not, we can say it is not present. Correct. So if you can think of, it is very similar to using the binary search, or to be even more precise, it is similar to, you can say, the binary search tree traversal. Correct. Because in binary search tree you use that sorted property, correct, and based on that you always either move to the left child or the right child, because the right subtree would have values greater than the root and the left subtree would have the value smaller than the root, correct? So in that case we can simply move to one of the children, correct? So either you go to the left side or to the right side. In similar way, for point search we are doing that. We will only go to one specific quadrant, one specific child. We don't go to multiple places because we are doing point search here. So this is the pseudo code of what we discussed here. Again, you don't need to remember all of this. It's just we discussed about it so that you get bit clarity, and it is very similar to as we discussed like BST. So if you solve BST related problems regularly, so this would be quite simple for you. So you would be also able to do such kind of things, okay? But normally if we talk, this is kind of the pseudo code of the approach, and the time complexity would be on average log n. Now let's see what are the pros and cons of QuadTree. Let's first talk about the pros of QuadTree. The major advantage of QuadTree is that it is adaptive to data distribution. Now what does that mean? It means like if the area is dense, then we will go deeper into the QuadTree. Right, we saw in an example, right? Say if the threshold is kept as 3 points and say here we have like 4 points, okay? So we will split it into 4 half, correct? And again now say here you get 2 more points, then you will split it further like this, correct? So clearly you can see we are splitting the area which is more dense, and here you can see we have not done any splitting here where there was no point, correct? So in the dense area we will do the dense splits, whereas for the sparse area or the area which is empty we won't do any splitting. So that would result in the shallow tree in this part, whereas the deeper splits in this part. So our quad tree is quite adaptive to the data distribution. So as an example, let's say we are talking about Delhi. So in Delhi you have a big business, there are many drivers, so you will have many splits in Delhi. Whereas if we talk about some desert area, you don't provide the service there, there will be no drivers and no splits. So you are not wasting any space indexing on the empty regions. Okay, the next benefit of QuadTree is that it works very well for the static or slow moving data. For example, if we talk about restaurants, cities, shops, buildings or any landmarks, these are generally static, so they don't keep on moving frequently. So in these cases where data is static or slow moving, QuadTree works very well. So basically you have to build the QuadTree only once and you can query it many times. One more advantage is that QuadTree is simple and intuitive. So it's easy to explain and easy to visualize. So these were some of the pros related to QuadTree. Now let's see some of the cons related to QuadTree as well. Now the biggest con related to QuadTree is that it is not great for dynamic data. So we talked in the pro part that it works well for the static data, but the con comes that when we talk about highly dynamic data, for example the user location or the driver's location keeps on changing, in that case QuadTree doesn't work very well, because as per the updates you also need to modify your QuadTree. So you have to perform frequent removal and insertion operations. Your tree becomes unstable and it would result in high CPU cost, and that's why we don't use QuadTree when we have the case of highly dynamic data. Like for example, in the case of Uber, we don't use QuadTree. Another issue is that your QuadTree can become unbalanced. So there can be a case where you are performing multiple deep splits in one region and other regions stay shallow. We saw that as one of the pro as well, but in some situations it can also result in a very unbalanced kind of structure. Okay, one more con is that it is hard to distribute across the machines. Also in the pro part, we mentioned that it is conceptually simple and intuitive, but if we talk about implementing the QuadTree correctly, it can be a bit complex. So generally we don't implement the complete QuadTree. Okay, so after this, the next question which comes to our mind is, when should you use the QuadTree? You can use the QuadTree when your data is mostly static, because QuadTree works well when we talk about static data. And we talked about QuadTree because we started this topic related to location. So if you are working on location and you want range queries, for example, you want to find out location within 5 kilometer radius or such kind of range queries, then we can use QuadTree. Another point is when the data distribution is highly uneven. For example, we saw the case like you distribute only when you have more points as compared to the threshold. So it can result in some of the areas we have like deep splits, whereas some of the areas stay like shallow, right? So in case your data is uneven, QuadTree is good for that, because QuadTree is adaptive to the data, and we can use QuadTree if we are working in GIS engine and in memory spatial index, because in that we can directly use the QuadTree. We'll discuss about that later, but yeah, we can use in these kind of situations. So some of the examples are, if you want to find out like the restaurants in a particular city, then QuadTree is good. Why? Because the restaurants are acting as like the static data. So if you have a restaurant in one place, correct, so it will be kind of static, it won't keep on changing. So that's why you can use QuadTree in such kind of situation. So this was about when to use a QuadTree. The next question comes into mind is when not to use the QuadTree. Okay, the answer is when your data is highly dynamic. Like we see the example of Uber, where driver's location will keep on changing every second, right? So in that case, QuadTree is not great. Another point where QuadTree is not great is when you have very frequent updates. The same example we can pick here as well. The driver's location is keep on changing. So if you are using the QuadTree, you will have to update the QuadTree very frequently. So the cases like Uber drivers or the delivery agents, in those cases, QuadTree is not that useful. Instead of that, what we can use is we can use Redis plus Geohash H3 S2. Don't worry about these because we are going to discuss about all of these later in this video. Alright, so we got a brief about the QuadTree with this. Now basically we want to move to the next topic, and the best would be to start with the Geohash. Alright, let's discuss about Geohash in detail. So the first question comes to mind is, what is the concept that we use in Geohash? So basically the core concept of Geohash is that we will convert the 2D location, that is the latitude and longitude, into a 1D key in such a way that the nearby locations will have the similar keys, and the 1D key that we have generated is the Geohash. So basically Geohash is the string representation of latitude and longitude. Some of the examples are, here you can see for Delhi we have this string represented as the Geohash. The nearby Delhi areas, it would have the string representation Geohash, something like this. And for Mumbai we have this. You can clearly see Delhi and nearby Delhi areas have quite similar Geohash. So the prefix here is matching for both of these, right? The complete string is not same, but the prefix, you can see there is a match for the nearby areas, whereas when we see the Geohash for Mumbai, it is quite different as compared to the Delhi, because Mumbai and Delhi are quite far away from each other. So as we saw, like Geohash is a 1D string representation of the 2D location, right? So longer the Geohash, it represents the smaller area. Now what does that mean? Let's try to understand with this example. Okay, all of these are the Geohashes. So these represent the locations, correct? So you can clearly see the number of characters in all of these Geohashes are different. This only contains 1 character, this contains 4 characters, and this contains 7 characters. So when you have very small Geohash, it basically represents very large area. Okay, here 4 characters represent like city level area, because we have like longer Geohash now as compared to this one. And here you can see like even more longer Geohash, this represents street level. So basically, longer the geohash, it represents the smaller area. Okay, now let's try to understand the core idea behind the geohash. So basically, the first step is we will divide the area. For example, for whatever area you want to create the geohashes, you will basically divide that area, and on repeat you will be cutting the latitude and longitude. Then basically what we will do is like we will encode the cuts as bits, and then we will convert the bits into characters. I know it might sound confusing to you, so don't worry. We will see an example and through which you'll get more clarity. So for example, we are talking about an area where we want to define the geohashes of all the locations, right? So latitude range of that area is from -90 to +90, and longitude range is, say for example, for -180 to 180. Now the step 2 would be we will split the longitude and the latitude, but we will do it alternatively. We won't do it like together. We will first do the split on latitude. If you remember, I told you that longitude represents the x-axis or the horizontal plane in terms of location. If you want to basically compare it with the maths like x-axis and y-axis, so x-axis was the horizontal one, right? Similarly, longitude represents the horizontal plane. Okay, so left or right you can say, or you can say east or west, correct? So that represents the longitude. So here we had the longitude range from -180 to 180. Now we want to make a split. We will split it into two halves. So it will become -180 to 0, one half, and 0 to 180 other half. So we can imagine something like this, because the x-axis or the horizontal plane represents the longitude. It was say -180, right? And this was 180. So this was our range. We are basically making a split here. So this will be 0. Okay, this is one region and this is another region now. So this area would be the left area, and this one is the right area, or you can say this is the west, this is the east, and this one will be represented by 0 as a bit, and this one will be represented by 1 as a bit. Now after this we want to make the second split, which will be on the latitude. So this was our longitude. Let me also define our latitude. Say our latitude was from -90 to 90, right? So here also we want to make a split at 0, correct? So this is 0. So -90 to 0 is one area now, and 0 to 90 is another one. So this will be the north or top you can say, and this will be the south or the bottom, correct? So for the bottom we want to assign the bit as 0, and for the top we want to assign the bit as 1. Just like we did for longitude, we are doing the same for the latitude as well. Okay, so basically we made the two splits. First split was on the longitude, and second split we made on the latitude, and this was our distribution. On the left we gave the bit 0, on right we gave the bit 1. Similarly on the bottom we give the bit as 0, on the top we give the bit as 1. So now we will keep on repeating this process like we mentioned here, correct? We will do this on repeat, like cutting the latitude and longitude, and whenever we cut, basically we assign 0 or 1 based on like left or right, top or bottom. So now once we have done this on repeat, we will move to the next step, which is the step 3. So let's check that out. So the step 3 is we will convert the bits into the base 32 characters. So every 5 bits would represent one character. Like for example, this represents U. So say we got something like this, correct? So for every 5 bits we will get one character. For example, this represents U, this represents 4, this represents P. Now how are we doing this? We are simply doing base 32 kind of encoding, and by doing this base 32 encoding we get our geohash string. For example, if we talk about only this, we get the geohash string as U4P. So one important point here is that all the nearby locations will share a common prefix. For example, if you see here, these are the geohash for 3 locations. Now all 3 of the locations share the common prefix, okay, and all of these are very close geographically. So based on the geohash we can easily identify if the locations are nearby or not. Now because we mentioned about the area with the geohash, correct? We said like longer geohash represent the smaller area, and this would represent very large area, this would represent city level, and this would represent the street level, right? So let's discuss about one thing which would come into your mind, that would be like geohash length versus the area size. So here you can clearly see, based on the length of the geohash, we have defined the approximate area. So if the length is 2 for the geohash, it represents a very huge amount of area, like 630 kilometers, whereas the length is 4, it represents 20 kilometer. Length is 5, 2.4 kilometer. 6 length, 0.6 kilometers. Length 7, only 150 meters, and length 8 represents only 20 meters. So larger the geo hash, you go very close to the area. You're talking about very small region then. So you will choose the length based on the search radius. The search radius is around like 2 kilometers, then like this length is good. If you want to do search on larger area, then you go to smaller geohash length, right? Like this or this. Now one question comes to mind is like how geohash is stored. Okay, one thing that may come into your mind would be like storing it in the database, like in SQL or NoSQL. If you want to know more about databases in detail, like difference between SQL and NoSQL and all the concepts related to database, you can refer to this crash course where I have explained about database in complete detail. So you will get complete clarity about database. So after this video, go check out this video related to database. Alright, if we think we are saving it in the database, it can appear something like this. Say for example, we are talking about the drivers. So inside the drivers table, we have like driver ID, we have the latitude, longitude, and we have the geohash. Geohash is simply the string representation. So you can simply save the string, right? And then what we can do is like we can index on the geohash to increase the speed, like so that you get low latency when you perform the query on the database, right? So your query can look something like this. You are doing like select star from the drivers table where geohash is like this. So basically we want to do the prefix match, and based on the prefix we are trying to identify the nearby locations, correct? So as we have made the indexing on geohash, the query will be very fast. Again, if you want to know about the indexing and other concepts related to database, refer to this crash course video of database. Okay, so this is one way of thinking, like storing the geohash in the database, but a very efficient and a wonderful way is using the Redis with the geohash. So here it is, the better and efficient way, use of Redis, and this is used in a lot of real-time systems. Okay, so in Redis we have like key value pair, correct? If you want to understand about like the Redis as a database, you can refer to this crash course of database, you'll get more clarity. If you want to understand about cache in generic, you can refer to this video where I've talked about all types of cache in detail, and the distributed cache in detail. So go check this video out. So if we use the Redis, the key will be the geohash cell and the value would be the set of driver IDs. So for example, if this is the geohash, these are the driver IDs which are present in that geohash. So at a particular location, you can say, or a particular geohash cell, you have multiple drivers which can be present, right? So you have mentioned the driver IDs, like all the drivers which are present in that particular region. So using Redis with the geohash is an amazing combination, and it is used to design many systems because this can handle the situation of like dynamic locations very nicely. Let me show you how. So say we are having the dynamic data, like the driver is moving, correct? So what we will do is like we will recompute the geohash based on the new latitude and longitude. We will create our new geohash, that is the 1D string, and then what we will simply do is like we will update the Redis. Now because Redis is like key value pair, it will be very quick. So this will be done in O1 complexity, and this will be very fast and cheap. So that's why with geohash we can use a combination of Redis, and that can be used to design many systems related to location. So the combination of geohash and Redis, right? So this is great. So I'm putting a star here. Now I think one question may come into your mind would be like, because we did like split here, correct? So here we split first in longitude and then in latitude, and here also but you may think like here also we are having like 4 kind of regions, right? So how is like geohash different from the QuadTree? Because in QuadTree also you have like 4 different regions after the split. Here also when you are doing the splitting, you have like 4 regions now. So how is geohash splitting different from the QuadTree? So the answer is yes, conceptually it looks the similar, correct? Here also we are having the 4 regions after the splits, same as in QuadTree. But if we talk in terms of implementation and structure, then the geohash is different from the QuadTree. Let's try to understand that in detail. So when we talk about QuadTree splitting, we basically split both the latitude and longitude at the same time. So basically it directly creates something like this, where you have like northwest, northeast, southwest, southeast. Basically you split it into 4 halves directly. So that's 4 regions at once, which means on every split you will have 4 children, and that's why it's called quad tree. Quad represents 4, correct? So every time you make a split, you'll split it into 4 halves. But if we talk about geohash splitting, it is a bit different from quad tree splitting. Here in geohash splitting, we do it alternatively. First, we split on longitude, as I told you, like on the x-axis you can imagine, or horizontally. We split it into 2 halves, like left side is given as the bit of 0, right side given as bit 1. And then we split on the latitude, which is like vertically, again the top one given as 1, bottom one given as 0 bit, correct? So we are splitting alternatively. We are not splitting it in 4 halves in one go. We are first splitting horizontally, then vertically, and then again on longitude, then latitude. So it's alternate process. So basically in geohash splitting, we do the binary splits one dimension at a time. So the main point is, in geohash we do the splitting in such a way that finally we have flattened the thing into a string, because in geohash our final kind of output is a 1D string, which is a representation of the location. Whereas in QuadTree, we always split into 4 halves, and that is stored as a tree structure only, correct? Whereas in geohash, the final output is the 1D string. So this approach in geohash is to flatten the complete system into 1D string. In QuadTree, you store basically nodes and the children, correct? Whereas in geohash, you store the 1D string. So geohash is very friendly when we talk about storing it in the database or in the Redis cache, correct? Because you have to simply store the 1D string. You have to simply store a string. That's so easy, correct? And even if you want to visualize thing, basically if you are trying to do the splits in geohash, it appears like a binary tree. It doesn't appear as a 4 array tree. Whereas for QuadTree, it's always like 4 children, correct? So even visually, these are different. And basically in geohash, we will do the splitting in such way, like at the end we get like a flat kind of structure. So overall, when we talk about QuadTree, it's kind of like 2D splits. On every split you have like 4 children, and this comes out as a recursive tree. Whereas when we talk about the geohash, it is like a 1D binary split, because you are doing split on one dimension, either on like the x-axis or the horizontal plane, and then on the y-axis or the vertical plane, first on the longitude and then on the latitude, correct? So it is 1D binary split, and then we basically assign the bits to it, and then we convert it into the string using the base 32. So both QuadTree and the geohash, they both of these divide the space, but geohash converts the space into a sortable prefix searchable string. So geohash is very smooth kind of process. You can imagine, like, you are simply storing a string and it's easier to work on that part. So if we talk in terms of like QuadTree versus geohash, so geohash is much more preferred, and combining geohash with the Redis, it is amazing, correct? Because your search is very quick and it's like key value pair, so things are very quick and fast and easy to do, right? So after covering geohash, now let's discuss about S2. So S2 library is developed by Google. So the question comes into mind is, what is S2? We saw that in QuadTree, we converted the plane into 4 parts, correct? And in GeoHash, we converted the location into a string. Now, when we talk about S2, it converts the Earth, which is sphere, into a cube. So you can imagine something like this. This is our Earth, which is spherical, right? And in S2, this sphere is projected as a cube. So now, because we have projected it as a cube, hence it has 6 phases. And then what we do is, like, for each of the phase, say for example if we talk about this phase, Okay, so we divide it into 4 parts, just like we did in the quad tree. And as we know, as we go deeper, then further it will be distributed in 4 more parts. So S2 is similar to quad tree, but we are not doing it on the plane. We are doing it basically on the cube, which is projected on the sphere. And based on our distribution, we also assign a cell ID to each of the cell. So let's revise this part again. Okay, so we know that Earth is spherical, correct? But in S2, what we are going to do is like we will project the sphere onto a cube. So here you can see this is our Earth and we have projected it onto a cube. Now cube has 6 phases. So we will have 1, 2, 3, 4, 5 and 6. So the first step would be identify the cube phase. Say for example, we are talking about this phase. Now step 2 would be each phase behaves like a quad tree. Say for example, we are talking about this phase. So we will split it into 4 cells like this. Okay, like we did for the quad tree. The only difference being in quad tree we did on the plane, but here we wrapped the spherical Earth around a cube. But here we projected the sphere onto a cube, and then on each of the face of the cube we are doing this distribution. So we split it into 4 parts, and then as we go deeper, each of the part will be further split it into 4 parts, and then each of the cell will be provided a cell ID. Now in quad tree, when we used to divide, we used to assign the positions like northwest, northeast, southwest, southeast. Instead of providing these directions here, what we give is a number like 0, 1, 2, 3, because we are distributing in 4 parts. So 0 to 3 would be the number instead of the direction that we used to give in the quad tree. Now a question comes to mind. What is cell ID here? So the answer to that question is basically, as we said, like first we need to identify face of the cube, because we projected the sphere as a cube, so it has 6 phases. So first of all, first step would be identify the phase, and then after that, because we have then distributed the phase into 4 parts and then again into 4, then we will have that kind of sequence. Because as I said, like in quad tree we used to had like northwest, northeast, right, and southwest, southeast. These were the 4 directions we used to give when we did the distribution, correct? But in S2 we will do something like 0, 1, 2, 3. Okay, so we have these numbers. So the cell ID would be the combination of phase and then the distribution that we did. So for example, for phase 2 you will have child 1, child 3, child 0, child 2. So it would be something like this, and the cell ID would uniquely identify the cell. Of course, you don't need to remember this, or you don't even need to like think how will I assign this, because you will eventually simply use the S2 library which is provided by the Google. But just to give you a brief idea, this is what it looks like. Basically you are projecting as a cube, and then for each of the face of the cube you are basically doing the distribution. Now another question would come into your mind is, like we said, like we would have a path like this for the cell ID. So how will we store this cell ID? So answer to this question is basically the S2 converts this path that we had into a 64-bit integer, and then basically that is the cell ID which is stored. Now the internal details we don't need to go into because it would complicate the things for us. Let's try to keep it simple. Basically, as we know, like we have reached to a point, like we have the path. Okay, so the S2 will basically convert it into a 64-bit integer. That is your cell ID, and that will be stored. Now the next question that comes into mind related to cell ID is like, where do you store it and what is the use case? Basically, to answer that, as we have already discussed, each cell will have a unique cell ID, and that would be 64-bit integer. Now internal details are like it uses Hilbert curve and it maintains ordering, due to which it is like specially local in 1D, but you can ignore that part. We try to keep it simple here. Okay, let's try to understand the benefits of using the cell ID. So one good part is, because it's a 64-bit integer, you can simply store the cell IDs in the database, right? Another good part is, because it is a simple like integer and we are putting it in the database, we can also do the indexing on them. Now what's the use of indexing? Using indexing, you generally are able to increase the query speed. If you want to know in detail about indexing, refer to this 8 hours crash course video on database. You will get complete understanding about the concepts in database like SQL, NoSQL, indexing, sharding, replication, partitioning, joins, normalization, and much more. Okay, so go check out that video, that is really helpful. Apart from indexing, we can also do range scans on interval on the cell IDs. Okay, so that's why cell ID is an important concept when we talk about S2 library. Now we mentioned that for each of the phase of the cube, we will basically do the distribution, like we will divide it into 4 parts, right? And then we will have the cell, and we also said like we can again distribute that cell into 4 parts. So the question comes, how big is a cell? So basically the size of cell totally depends on the precision that you require. It's obvious that a huge cell would represent a very big area, like you are talking about a continent, whereas when you're talking about a very small cell, it can also represent a very small area like a street you are talking about. So it totally depends on your requirement. Say you are talking about few kilometers, like nearby areas within few kilometer range, so you will choose smaller kind of cell area for that, correct? And basically the good part is you don't need to memorize the sizes. Actually you can choose the level experimentally, or basically you can use the library helpers to choose the particular cell size. Now after this, the next question that comes into mind is like, how do we store location using the S2? Now as we discussed, like we will have a cell ID, correct, which is a 64-bit integer. So in the database you can store something like this. Like if we are talking about the driver case, like we have the driver ID, we have the latitude and longitude, which is the location of the driver. Now you will store these in the database, but apart from this, you will also store the S2 cell ID, which we just calculated, which is a 64-bit integer, correct? So we will store both the lat long, which is for the exact distance check, and the S2 cell ID, which is for fast lookup. Okay, so apart from that also you can have whatever metadata information that you require, like updated at timestamp or whatever, but the important part is you are keeping both of these, the lat long as well as the S2 cell ID in the database. Now another important point here is, like we talked about the database, correct, but we saw like in QuadTree there was an issue when we talk about like changing or dynamic locations, correct? Say the driver keeps on moving, right? So that was a problem in QuadTree. So how is that handled in S2? Like we talk in Geohash, correct? In Geohash we used to have like a string which could be stored in the database, right? And then you also used Redis for it, so that in case you want to fetch that quickly, then you can do it from the Redis, correct? So in similar way for S2 also, it is good for dynamic locations if the location is changing. So again you can calculate the cell ID, because you calculate the cell ID using the phase and then the distribution that is happening, right? So it's a 64-bit integer only which is stored in the database. So once you calculate it again, so you can update that cell ID and you can maintain that in Redis. So similar to geohash usage of Redis, you can also use it in the S2. So in that way you can handle the dynamic location case in S2. Now next, let's talk about like how do we handle the range search in S2, which means like if you want to calculate like the drivers or the areas within like 3 kilometer range, how do you do it in S2? Now we will try to keep it simple. We won't go in very much detail into it because I don't want that things become very complicated for you to understand, right? What I want is like you have like brief understanding of all the concepts like the quad tree, geohash. We are talking about S2, and then we will also talk about H3, and then we will also see like while designing systems like Yelp, Yellow Pages, or Uber or Google Maps or Tinder, which all of these can be used. So we'll talk on those terms, but I don't want to overcomplicate things. I'll just give you a brief. Okay, try to get a brief knowledge about it, but don't worry too much if you feel it bit complicated. Okay, so first of all we are talking about the range search here, because most of the times what we want is like we want to check like drivers present in like nearby 3 kilometers or 5 kilometers or whatever is the range we are talking about, correct? So that is range search. It is quite rare if we are talking like we want to check for particular location point, like you want to search for particular lat long. That is not heavily used, that is not a very realistic kind of example. So most of the times when we talk about location searches, it is generally related to the range search, which we need to focus more on. So that's why we are talking about the range search here. Like for example, when you try to search the nearby petrol pumps, so what it does is like your current location, it already has the lat long, so it tries to basically find out the petrol pumps or fueling areas like within the range of like 3 kilometers or 5 kilometers, or you can say like 3 miles, like that, right? That is range search. Similarly, when we talk about Uber, so when you are trying to like book a ride, what it tries to do is like it tries to identify the nearby drivers around you, right? So this is also range search, like all the drivers within 3 miles to your location. So that is all range search, correct? So what we are doing here is, first of all, create a circle with your center. It already has like, and the radius, like for example, we are taking like 3 kilometer here. It can totally depend. Say for example, first you try 3 kilometer range, but if you don't find any drivers in 3 kilometer, you can widen your area to 5 kilometers, like this you can do. So by default we are taking it like 3 kilometer is our range that for which we are searching. Then what we need to do is like, we will simply use Google's S2 library to compute a covering. Now what is covering? We will try to understand that after this, don't worry about it. But basically what we are doing is like, from your location we are trying to find out a set of S2 cell IDs which are within 3 kilometer range. Okay, and that we are getting from the Google's S2 library. We are not calculating that manually, we are getting it from the S2. So we get a set of S2 cell IDs that basically cover the circle, because we said like we are creating a circle. So say this is your location, so we are talking about 3 kilometers, so this will be the circle, right? Because we know the center point and we also know like what region we are talking about, 3 kilometer, right? Now that we have the cell IDs, what we will do is like, we will fetch the candidates in those cells. So in each of the cell, if we are talking about the driver IDs, so we will find out the driver IDs in each of those cells. Once we have that, what we will do is like, we will find the exact distance between that particular driver to our location. We can use Haversine formula or anything else. Basically we have 2 points with lat long, we just need to calculate the exact distance, right? So we can do that. So this is kind of the strategy which is used for range search in Google's S2 library. Now the next question, as we discussed about covering here, so what is covering in S2? So basically covering is that it will give you the list of cell, like for example it provided you a set of cell IDs here, right? So it will give you the list of cells that cover the region. Here we talked about like 3 kilometer radius circle, correct? So in that, what all cell IDs were present, that was provided by you the S2 using this covering. So basically covering means like it provides you list of cells which cover that region. So like we took this example, we were talking about radius of 3 kilometers, so it might cover around 20 to 30 cells. Just an example, it can be any number, but basically it provides you all the cell IDs which are part of that region. Now the good part is this is computed by the S2 library, so you don't need to do it manually. And there is one more property that you can use. You can put like max cells here, like for example if you put like 20, so it will give you maximum 20 cell IDs. So this was about covering and range search in Google's S2 library. Now after this, the next question is like, how do we query efficiently in database for S2? So there are two options. First option is you can use in keyword. Basically, as we already have the cell IDs using the covering, or basically through the Google's S2 library, we got the cell IDs, correct? So what we can simply do is like something like this: select star from drivers is the table where S2 cell ID, we use the in keyword. So it basically matches from this kind of, you can say, list. We have provided like multiple cell IDs here. So whenever we find a basically match for this cell ID, we will provide that. Okay, and once we get the detail from this, then we can basically use that formula to find out the exact distance between the driver and your current location. Right now this is fine if we have like cell IDs in range of like 10 to 50. Okay, in that case we can use like in keyword, and using that we can do the search. Now apart from this, the second option is using the interval scan, which is advanced option and faster as compared to this one. So basically, as we said, like each of the cell will be given a cell ID, right? But each of the cell will also have the range, like we have like starting point and ending point, and that is kind of the range of the cell. So what we can do is, like in the query we can use something like this, where is the condition, correct? So we can say like the cell ID is between this range, right? We have given the starting and ending point, and then we have used or keyword because we want to find out for all the cell IDs, right? So for that we are using or here, and then again we will provide the next range. So we have the starting and ending point of each of the cell, and we can use that range for this optimized kind of query. Again, you don't need to remember this, but it's just like good to know kind of thing. Now after this, the next question is related to the dynamic locations. Although I have discussed in brief about it, but still it is kind of a major question that comes to mind, which is like how do we handle the dynamic locations like drivers are moving in Google's S2 library. So basically when we talk about the moving objects, what we will do is like we will recompute the cell ID, because cell ID is just a 64-bit integer which can be stored in the database, right? And you can also keep that in Redis for faster kind of access. So because we know that we are dealing with the moving objects, like for example the driver's location will keep on changing, what we can do is like we can recompute it after every few seconds, like 3 to 10 seconds you can keep it as per the requirement of your product. You can do that, but you can simply recompute that and then you can update the storage. So now because we are talking about like say every 5 seconds we are recomputing it, updating it in the SQL or your database won't be that much feasible. So what we would prefer is that we would use Redis for real time, just like we discussed for Geohash as well. So similarly here we will use the Redis, and we will have key something like S2 cell ID which we will compute, and then we will have the value. So in the value we will have the set of driver IDs which are present in that cell, and then what we can do is like we can periodically sync it to the database so that the database doesn't get overwhelmed with so many write requests, right? So if you want to know in detail how do we handle like this scale and like so many write operations in database, you can refer to this 8 hours crash course video of mine, through which you will get the complete understanding. Like we will do, like here as we said, like we will do the periodic sync instead of like every time hitting the database. Similarly, we will also perform the write operation in batches instead of like for each of the request updating the database. We'll basically make a batch request and make a write operation only once in a while, right? So that kind of concepts you can basically refer to this 8 hours crash course video. In this you will also learn a lot of concepts like SQL, NoSQL, time series database, Elasticsearch. What are the differences between all of these? How do you handle a lot of reads and write operations, joins, normalization, sharding, indexing, and much more? So refer to this video, it will give you a lot more clarity. Okay, and then when we talk about within 3 km, we can get the covering cells, and then we will use the union sets from Redis, and then we will use the distance filter to basically calculate the actual distance between those points. But overall the main concept here is that because cell ID is like 64-bit integer, so you can simply recompute that value, and you can use Redis for real time, and for the database you can update it periodically and do a batch kind of write instead of writing for each of the requests. Okay, so in that way you can handle the dynamic locations. All right, so after this let's discuss what are the pros and cons of Google's S2 library. So first, when we talk about the pros, it gives you more precise results as compared to what we discussed in like the Geohash, because it is kind of you have wrapped the cube across the sphere, and actually the shape of earth is spherical, right? So it gives you more precisions, it is more correct globally. And like we discussed about the covering concept in S2, and that is handled by the Google S2 library itself. So the API is quite powerful. The library that you are using, it provides you that functionality, that it can provide you all the covering cells. And talking about the cells, we have the cell ID, which is a 64-bit integer which can be stored in database. So when we compare it with the quad tree, so you can store this cell ID in the database, correct? And you can also index this cell ID, which would basically improve the speed of your query, because you would query based on the cell ID, right? So the cell ID concept is helpful. And S2 library is kind of like widely used in large scale geo systems. So it is kind of a trustful library that we can say. So we have like hierarchical levels in it, and it gives you more precise data, and the library itself is quite powerful. So these are all the pros of this S2 library. Now next, when we talk about cons related to S2 library, it is basically bit harder or complicated as compared to Geohash. Geohash is like more simpler kind of thing. S2 would be more complex as compared to the geohash. Now we talked about the covering part as a pro, but it can also come in some of the cons part, because it can return you many cells if you choose a bad parameter. And debugging like why the covering return this cell ID, that can also be a bit complex to handle. Okay, so overall you can imagine like S2 library is bit complex as compared to the geohash. So after this, next question that comes to mind is when to use S2 library for location. So we can use Google's S2 library when we want production grade geo indexing. Of course we use it for like location related things, but it can be used when you want like accurate nearby search at scale. It can be also used when you want hierarchical grouping like city, locality, street. So from like bigger areas to very small areas, it can provide like precise information on that related to locations. Okay, so talking about the next question, it can be like what is the difference in approach between QuadTree versus the GeoHash versus S2 library. So let's discuss about it. So first, when we talk about QuadTree, the first split that comes in QuadTree is on the whole region. You select the region first, and then you basically divide it into 4 parts, correct? When we talk about geohash, the first split is on the longitude. After splitting the whole region, then the subdivision in QuadTree is like 4 parts: northwest, northeast, southwest, and southeast, correct? When we talk about geohash, the first split is on the longitude, and then it is on the alternate bits. Like first you do longitude, then latitude, then longitude, then latitude, like this, correct? Now, when we talk about S2, the first split is we split the spherical earth into 6 cube faces. And then when we talk about the subdivision, it is like for each of the face of the cube, we distribute into 4 parts. So it will be 0, 1, 2, 3, and it will be done recursively. So majorly if we see the difference between geohash and S2, in geohash we do the split in lat and long directly. Whereas when we talk about S2, the spherical earth is projected into a cube. So S2 provides better spherical accuracy as compared to the geohash, because geohash produces rectangular grid and fixed cell shapes. Now after this, the next question which comes into mind is how do we identify cell in S2? So answer to this question is we don't manually compute it. We basically use the library. So here is an example. Here you can see we have calculated the cell using the library. So we have used the method from the library itself, and we have not manually computed it. And through the library we will get the cell ID, and cell ID will uniquely identify the location. So you can clearly see most of the work is done by the library. You don't need to do things manually, and that's a great thing, right? But here we are just trying to understand the basic concepts related to various things that can be used for location. Another difference between the geohash and S2 is in terms of how do we do indexing in database, or how do we do the search for geohash and S2 in DB. So as we know, like geohash provides you a string, right? So the string is stored in the database, and when you need to do the similarity related search like nearby areas, say this is the geohash, you will do where geohash like this string, because we want to get the nearby areas as well, and this works well with the B tree. When we talk about S2, now in S2 we don't have a string, we get the cell ID which is 64-bit integer. So we will do something like where cell ID is between X and Y, and this works very efficiently with numeric indexes. So clearly you can see the difference, because geohash provides you a string whereas S2 provides you the cell ID as 64-bit integer, and that's why there will be different strategy that will be used in terms of how you search it and how you index it in the database. By the way, if you want to know in detail about the concepts in detail about like what is indexing and other concepts related to database, you can refer to this crash course video of 8 hours where I have explained everything in detail. So I highly recommend it. Like after watching this video, you can check out this video and you will get a lot more clarity. The major high level difference between GeoHash and S2 is like in GeoHash, it splits latitude and longitude directly into a rectangular grid. Okay, so you can imagine it takes it like the flat word and then divide into rectangles and encode that into strings. So finally you get the string, right? But overall it takes it as a flat word and divide into rectangles. Whereas when we talk about S2, it projects earth, which is sphere, onto a cube. Okay, and then recursively subdivides the cube face. Like each of the cube face, it divides into 4 halves and keep on doing that recursively. So we have the earth as spherical and then it wraps it with the cube and then subdivide each of the face of the cube. And finally what we get as cell ID is 64-bit integer. Now because GeoHash assumes it as a flat word and divides into rectangles, the accuracy near the poles is not that great. Whereas when we talk about S2, as it takes like the sphere and then wraps with the cube, so it has better accuracy as compared to the GeoHash when we talk about the poles or the boundary cases. The next component, which is H3. So H3 is also widely used when we talk about handling the locations. So the basic question that comes into mind is, what is H3? So H3 is hexagon based grid system. So if you want to remember that in easy way, like H, you can remember it as like hexagon, right? It also turns like lat long or the location into a cell ID, just like we did for GeoHash or S2. But the major difference is here the style is following the hexagons, through which it provides very high accuracy. So just to remember H3, so H you can remember as like hexagon, and when we talk about S2, so S stands for sphere, so sphere onto a cube. So H hexagonal, S2 spherical with cubes. Now like S2 library is created by Google, H3 is created by Uber, because in Uber a lot of information or data or work is related to location, right? Location of driver, location of the user, and following the maps, correct? So for that use case, for high accuracy, Uber has created this H3. So in H3, Earth is divided into hexagon cells and each cell has a unique ID, which is usually shown as a hex string like this. Now you can see here we have mentioned like H3 equal to Earth divided into hexagon cells at multiple resolutions. Now what does this resolution mean? It is very similar to what we discussed earlier, like the cell size can vary, right? Like if you have like bigger cell size, it shows like bigger area. When you go into smaller cell size, it means you are going into smaller regions like street level, correct? So similarly, as we have cells in terms of hexagons here, so like resolution also means like how big is the size of the hexagon depending on what use case is this, right? If you want to see at like country level, of course you can have at the bigger picture. If you want to see like nearby 3 kilometer areas, you would like to see like smaller hexagon rings. Now an obvious question that comes into mind is like why hexagons are used in H3. So basically if we talk in terms of like square grids, when we which we took in GeoHash case, it had like issues like neighbors are uneven, and because we are using the squares, so the distance rings look jagged. So overall when we take like square shape, we talked about the boundary cases or even at the poles, the accuracy was not that great. And when we talk about hexagons, it gives like uniform neighbors. So every hex has 6 neighbors. It gives smoother rings and more consistent adjacency for nearby search. I mean, we don't need to go in that much detail eventually, but you can simply say that H3 gives you more accurate results in terms of locations as compared to GeoHash. So for that it used like hexagon pattern. Now, of course, you can always go into more detailed discussions, even into maths and more precisions, like how does this actually help, like using hexagons versus the cube versus the rectangular area. But to be honest, that is overall not required when we talk in terms of like the interviews, right? Even in interviews, I think generally if you say like you will use H3 or S2, that is more than enough, because that shows that you have some idea about all these fundamentals or what all options are present when we talk about handling location, right? If we go in detail, like why hexagon, why sphere, why cube, how is it exactly better in terms of maths, it can overcomplicate things, right? And we want to basically try to understand the overall scenario, how to handle locations different ways, so that when we are designing our system which like has data related to location, we can basically take a decision based on that. So, and most of the work in this is done by the library, even when we saw for S2, correct? So you are not manually calculating the cell ID. So that is done by the library. So eventually, if we simply understand the basic concepts of these libraries, that is more than enough. But yeah, just in case you are more curious, you want to know more about like why this particular thing, put that in the comment section and I'll try to answer that for you. But for now, let's move forward. Okay, now let's move to the next question, which is how to store location related data in H3 for real systems. So when we talk about real-time moving objects, like the driver's location keep on changing, it would be very similar to what we discussed in Geohash and S2. In both of those scenarios, we use Redis, and even in H3, when we talk about real-time moving objects, we will use Redis. So we will keep it something like this: driver colon ID, and then corresponding to that we will maintain the hash. So basically we have like latitude, longitude, updated at, and the current cell. We are maintaining all of these information. Similarly, we can have information per cell. So for example, here if we talk about like for a particular H3 cell, this would be H3 colon. For example, here we would have key as like H3 and some information and the cell ID, and it would contain the set of driver IDs. So it will tell you at a particular cell all the drivers who are present in that area. So that will really help like whenever a user tries to book a cab, correct? So you'll get all the set of drivers in that particular cell and you can basically try with all those drivers. And because this is real-time moving kind of location, so you will keep on updating it after every 3 to 10 seconds depending on the scenario or the use case of your product. And in case it has changed, you will update it in the Redis again. Okay, next let's see the difference between H3 and Geohash. First, if we talk about the advantages of H3, in H3 the neighbor logic is simpler. It provides 6 neighbors or rings. Another advantage in H3 is that if you have to search in nearby areas like within 3 kilometers or within specific regions, those approximations feel more circular or more precise, you can say. And H3 is also great for aggregations. When we talk about the advantages of Geohash, Geohash is much more simpler, because in Geohash you get the string, so you can do like string prefix related queries, like you need to search for similar strings with this kind of Geohash, and by doing that you will get like nearby rings or cells. So geohash is very simple as compared to H3, and geohash is also easy in SQL even without using any special libraries. So the basic summary can be like geohash is very simple, but if we talk about more precision, then H3 is better. Now let's also see H3 versus S2. Of course, we know that the fundamental differences between these, like for example in S2, the spherical earth, around that we wrap it around the cube, and then for each of the phase of that cube we divide it into 4 parts, and we keep on doing that recursively, whereas in H3 we use the hexagon approach, right? But apart from that, let's see some of the advantages of H3 and S2, and let's see how those are different. So first, if we discuss the advantages of H3, as we said like earlier also, it provides like hex grids which feels natural for the area buckets and the rings. H3 is also great for aggregations and analytics, for clustering, and its API is very friendly. Now when we talk about the advantages of S2, S2 has very strong covering for arbitrary shapes. As we discussed earlier, H3 is developed by Uber, S2 is developed by Google. So S2 is widely used in Google ecosystem. For S2, there can be great database indexing via intervals. If you want to know in detail about indexing, refer to this 8 hours crash course video on database, and through that you'll get a good clarity about it. So clearly you can see Geohash is very simple. If your use case or product is not that complicated, you can always go for Geohash, and for dynamic things you can use Redis with it. But if we talk about more precision, if you have like complicated, more complex queries, then you can go with H3 or S2 depending on the requirement. Okay, so now we have discussed about quad trees, geohash, S2, H3. So one question that came into my mind was like, do we implement ourselves like quad tree or geohash, S2, H3, or do we use the libraries? So this was a question which came to my mind. You might also be having the similar kind of question, so I thought like I'll discuss about it. So the answer to this question is you mostly always use the libraries. You don't need to manually implement these things. Let's talk in brief about each of these like QuadTree, Geohash, S2, H3. Alright, first when we talk about QuadTree, usually we don't implement it ourselves. We mostly rely on either the database special indexes like rtree, gist or postgis or postgis, or we use like other GIS engines or libraries. If we try to do it like manually, so the point is like implementing it correctly is tricky because we have to handle all the different cases like splits, deletes, branching, intersection, all the maths that is involved, and that is not required. Basically you should know like the basic fundamental of that, like how is it working, but you don't need to reinvent the wheel. Okay, you can simply use, in case of quadtree, these database special indexes, and using that you can simply use a quadtree, so you don't need to manually do it. Okay, so you can remember like using rtree or postgis. Okay, inside that you have like gist, so you can use gist in this postgis, and through that you can directly use the quadtree. All right, so after quadtree, let's talk about geohash. So again, for geohash, as we said for quadtree as well, so often we use a tiny library. Although geohash is quite simple, but mostly what you can do is like use an existing geohash library, or in case required you can implement a small helper, but still the preference would be using the library so that there is less bug risk. And another point is, because this functionality is already present, why do you need to implement it by yourself? You can invest your time and energy in better things, right? You can just use the existing things and then try to build up some better scenarios out of it, right? So again, for geohash you'll most of the times use a library. Okay, next when we talk about S2, you almost always use the official S2 library. So S2 has been developed by Google, so it provides the S2 library, so you always use that official S2 library. Why do we say that? Because S2 is complex, it is used for like complex cases and queries, so implementing it by yourself you can miss out a lot of edge cases. So it's better the official S2 library which has been provided by Google, you use that. So S2 library, it does like cube projection, Hilbert curve ordering, coverings, robust geometry. So you don't want to go inside all of these complications, right? So you will use the official S2 library for S2. Okay, next when we talk about H3, you almost always use the official H3 library. H3 has been built by Uber, so you use their official H3 library. Again, H3 is quite complex as just like S2, right? So you don't want to go into all those complications because it already handles like hex grid on sphere, resolution hierarchy, neighbors, rings, polygon fill, edge cases. So if you try to implement all of these by your own, it will be first a very big project, and then there are chances that you will miss out some of the scenarios, so you don't need to implement it manually. So clearly you can see for all of these cases we will mostly use like libraries or existing like spatial database indexes, right? So you don't need to implement it manually. For quadtree you can use database spatial indexes. For geohash you can use the existing geohash library. For S2 you can use the official S2 library, and for H3 also you can use the official H3 library. Okay, so here we said like for quadtree, geohash, S2 and H3 We generally use the library. So the question that comes into mind is like, what do you actually build yourself? Because you are using the libraries for all of these, so what do you actually do? All right, yeah, so like we said, like we don't need to reinvent the wheel, we don't need to manually implement like all these geohash, QuadTree, S2, H3, right? But there are some of the things that we need to do. Okay, so first is like the storage model. Like we need to define the database schema, like what all things that you need to store. You want to store the lat long, like the proper location, latitude and longitude, and apart from that you want to have that the cell id, which you generally will get like from different things that you are using. If you are using like geohash, from that you will get the cell id. If you're using like S2, H3, from that you'll get, but the DB schema you need to define. Okay, as we said, like we don't need to reinvent the wheel. So we will use the library for like QuadTree, GeoHash, S2, S3, but there are some of the things that we need to do. So let's talk about it. First is the storage model. Like you need to define the DB schema, like what all things you want to store. So for example, you will store the lat long. So for the location, you will keep the latitude and longitude in the database. And apart from that, you will also have the cell ID. Now cell ID, depending on whatever technique you are using, like geohash, S2, H3, based on that you'll get. But you need to store the cell ID in the database, right? So you will define the database schema. And then apart from that, you will also define the indexes, like based on which your query will be faster. If you want to know in detail about the basics of database and the indexes, refer to this 8 hours crash course video and you'll get much more clarity about all these things. So you need to define that, right? And then there can be other things like the TTL or the staleness fields. If you want to know in detail about TTL and cache things, you can refer to this long video. You'll get some clarity about it. Okay, so my recommendation after this video, you check out this 8 hours database video and also this cache video. You'll get much more clarity about the concepts of system design. Okay, next, as it says real-time indexing, but we have already covered that. Like it is mainly for that you have like faster queries, and even for Redis you want to provide keys by cell, so that based on the region or the cell ID you can directly get the list of driver IDs which are present in that cell, right? So that would be helpful. Next, we will also need to define the resolution, like the precision, because it totally depends on your product needs. Like what do you want, like within 3 kilometers, within 5 kilometer, 10-kilometer area, or what is the requirement? So you need to set that precision or resolution, and based on that a lot of things would depend, like the size of the rings, you can say, or the neighbors, all such things would be present there. So you need to take care of those things. And then of course you can also have some exact distance filters and ranking that you want to apply, like what all things you want to prioritize on, correct, based on your product requirement. And of course the basic system design things that you need to follow, like the rate limiting, batching, caching, hot cells handling, sharding strategy. So all these things of course you need to do. These are part of the basic system design whenever you are designing any system. So that won't be part of the libraries, right? Libraries will help you provide like the cell IDs. Like if you say like provide me all the cell IDs within 3 kilometer area range, the library can provide you that. Some other things also it can provide, like if you provide the location like lat and long, it can provide you the cell ID, but it cannot do the other things like rate limiting and sharding things. You need to figure out or handle by yourself, right? Now one more question that may come into your mind is like in QuadTree we said like we can use the database special indexes. Like database special indexes we said like we can use like PostGIS, whereas for S2, H3 we said like we'll use the official library. And geohash also we mentioned we can also use Redis. So there can be some confusion like why use like PostGIS for QuadTree. So the basic point is like as we mentioned, QuadTree is not very much great when we talk about like dynamic locations, right? If the driver's location is changing very frequently, the QuadTree is not very suitable kind of structure for that. QuadTree is generally for like static locations. Say for example, you have restaurants which like the location of that restaurant won't change very frequently, right? The fuel pumps, some of those things which like which when developed they stay there for a long time, those are mostly static locations, they don't keep on changing. Whereas dynamic locations, you can take the case of like Uber, right? So the driver location keeps on changing, right? So all those things you have to keep in mind. So PostGIS is fine when we talk about like static locations, but when we talk about dynamic locations, it is not great because it's a database and you don't want to put a lot of write operations into it, and it's not even useful because the read operations for that won't be that high because the location keeps on changing, right? Even if you put that in database, few seconds later the location will again change, so you are not getting that many reads even on that part, and it's not scalable, right? So PostGIS we mentioned for QuadTree actually, and which is mostly for like the static kind of locations. But when we talk about Geohash, S2, H3, when we talk about handling their dynamic cases, generally we use Redis for it because it's like very scalable. But still, it's a good thing that we discussed about like database special indexes. This is one of the things that can be used for like static or semi-static kind of locations, right? And when we talk about dynamic, we can use like Redis with the combination of Geohash, S2 or H3 depending on your requirement or whatever product case you have. All right, so till now we have discussed like about the basics of like all these things, like using QuadTree, Geohash, S2, H3. So now comes the main question. Like when you design systems like Yelp, Tinder, Uber, or Maps, what do you use while designing these? Will you use QuadTree? Will you use like Geohash? Will you use H3 or will you use S2? Alright, so here we go. When we talk about Yelp, generally the locations are more of static or semi-static because as we said, like the restaurant's location or the fuel pump's location won't change very frequently, right? So it's kind of like semi-static or static location, so we don't need like dynamic kind of location related things for it, so we can simply use like PostGIS for it, like the database spatial indexes that we discussed about, right? So we can simply use that because it's not a very complex product. Okay, the reason, as I said, the locations are static or semi-static, so in this we don't need to overcomplicate things, we can simply use database spatial indexes here. Okay, next if we talk about Tinder, it's kind of a product where location can change a bit because person's location keeps on changing because people change the cities as well, so they move around to different cities. So using PostGIS here won't be that great. What we can use is like, of course, because these are bit of dynamic locations, we can use Redis here, but apart from that we can use any of the strategies like S3, H2, Geohash, but I think it's not that complicated, so we don't need to make it over complicated. What I'll choose here is like we can use simply the geohash, and for dynamic things we can use Redis alongside it. And for other static, semi-static things, you can also use the combination of PostGIS with the Redis. Okay, but geohash is what I will go with. Okay, because I don't want to overcomplicate things. I think GeoHash will handle it, so it's good in that way. Next, when we talk about Uber, so again, you can use GeoHash plus Redis here because Redis will handle the dynamic cases of like drivers moving location, and GeoHash, as we discussed, like it can handle dynamic cases, right? But the point is like Uber has specifically created its own library which is H3, which handles these cases in much more better way. It provides much more precision and accuracy. Basically it uses hexagon structures through which you have like distributed rings, which covers the boundary cases as well and provides you more precision and accuracy. So I mean, you can go with geohash plus Redis if you want to keep things simple, but the better answer would be using the H3 and Redis here. And of course the overall like database that you need to use, you can use like database spatial indexes, so you can use like PostGIS. Okay, but overall if we see like which library or which thing we are using here, so we'll go with H3 plus Redis. Next, when we talk about Google Maps, again for this, like Google has specifically or officially created its S2 library, so the best answer would be to go with like S2 and spatial indexes, and of course you can use Redis for like dynamic cases. Okay, so a brief summary: for Yelp we can use like PostGIS, For Tinder, we can use like Geohash plus Redis. For Uber, we can use H3 plus Redis. And for Google Maps, we can use S2 plus Redis. Okay. Now that because we have like the basic idea or understanding of QuadTree, database spatial indexes, and then geohash, S2, H3, we know the basics, right? Of course, you can go in more detailed version of it, but that's not required. But we have like basic understanding of like how it works, which is simpler, which is more complex, right? When to use which one. So based on that, it's now a bit easier to choose in these cases, right? If you don't have proper understanding of like what these libraries do, then it becomes a bit tricky, like what should I choose. But here you can always go for a discussion. Okay, like for example, for Uber, even if you say like geohash plus Redis, that's totally fine. I mean, that's an acceptable answer because it will handle that case. But now that because you have that idea, you can also go with like H3 plus Redis, right? And you can tell like why you are going with it. So it tells like you have good amount of understanding and knowledge. And once like the interviewer knows that you have such deep understanding, that would be really impressive, right? And when we say like database spatial indexes, so it also provides you some of the features or functionalities or the methods, you can say, through which you will get like things in easier way. Like for example, in Redis, for the dynamic things, it will provide you like within 5 kilometers or whatever range that you define, it will provide you information for that, so that you don't need to manually do things like we discussed, right? So using like database spatial indexes or the libraries, correct? So these really help you to identify the things or cell IDs very quickly, and based on the cell IDs you'll get like all the information, like what are driver IDs are present in that particular cell. So in that way, these are really helpful so that you don't need to manually do all such things, correct? All right, so with this we have covered a lot of good concepts in this video. Of course, we can go in much more detail about some of the things, like how does range search works in each of these, like how does the range search works in like QuadTree or Geohash or H2 or S2 or H3, like all these things we can discuss, and more things we can discuss, like why we are going with like sphere, why we are going with the cube surrounded into the sphere for S2, and then basically dividing into four parts and all the geometry things, and even for H3 like why hexagon, all those things we can go into. But more or less I felt like that would be over complicated to discuss too, and it might not be actually required. What we discussed till now was like still very amazing things. If you know about these things, that is like cherry on top. I mean, because mostly you have to just design these kind of systems, and if you are able to tell like which one you use, that's more than enough. But here in this video we also discussed about all of these concepts individually, so that was great. In case you have any questions, if you want to go in more detail or any queries about whatever we discussed in this video, feel free to put that in the comment section and I'll try to answer that for you. Okay, all right, I hope you liked this video. In case you found this video helpful, press the like button, share this with your friends and family, and make sure you subscribe to the channel. All right then, this is Mohit Chabda signing off. Subscribe to the channel and thanks for watching.